special thank you to Albright this month for their immense support to this channel. Hello guys, and welcome back to the second episode of creating a third-person horse rival in Unity. So the first thing we're going to do is go up here and right-click in the hierarchy, and we're going to make an empty game object. Just going to call that player camera, if I can type it out correctly. Then we're going to go over here and reset the transform. Going to right-click, create another empty game object as a child. I'm going to call that the camera pivot. And then lastly, we're going to drag the main camera under the camera pivot game object. So the reason why we're doing this is because the player camera will be the object we use to rotate the camera left and right, and the camera pivot will be the object we use to rotate the camera up and down. So let's make a player camera script on the player camera game object, and we can get started implementing our logic. So the first thing we are going through at the top here is we're going to say public transform, and we're going to call that the camera pivot. Then we're going to say public, and we're going to have a variable of type camera, and we're just going to call out the camera object. I'm making them public so I can drag them in the inspector. Okay, and right below that we are going to say public game object, and we'll call this player. This will be the object the camera will follow. You can call it follow target if you'd wish. I'm just going to use player because we're only going to use this camera to follow the player. So then we're going to say public void handle all camera movement, and we're going to encapsulate our camera logic in here. So we're going to have the camera following the player, word function for that. We're going to have the camera rotating around the player, depending on what movement you have going on. And we're going to encapsulate that as well. So let's start off by saying private void follow player. And this logic is very straightforward. Let's go up here. We're actually going to need another thing here. We're going to say vector3. We'll call this target position. So this is where we want the camera to be. And we're going to say target position is equal to vector3.smoothDamp, and we're going to put that between the current transform.position of this game object and then the player. So we want the camera to be at the player. It's coming from where we currently are, and we need a reference velocity for our camera. So let's just add a variable and make that vector3.0. I'm just going to call it reference camera follow velocity, and the smooth time will be the camera smooth time, which we don't have make it either, times time.delta time. So let's make those two variables real quick. So right above the target position, we're going to say vector3 camera follow velocity is equal to vector3.0. And then right below all of this, we're just going to say float camera smooth time, and I'm going to initiate mine at 0.2f. That's pretty good. So 0.2f, 0.2 seconds for the camera to kind of smooth out. So let's make a header up here to keep it neat. We're going to call this camera speeds. And if any other camera speeds come into play, which they will, we'll put them right below that header. So transform.position is going to be equal to target position. So that's a very straightforward function, very simple. And now under our handle all camera movement, we can put that there. But first, let's go over here to the main camera. Let's drag in the main camera on the player camera script. Let's rename that camera object. I'm doing that just because I have the variable called camera object, and I like to keep my variables with the same name as the game objects that utilize them. That way, if anything happens, I know right where everything goes. So on the player here, let's make a new script. Let's call this the player manager. This will be the script that handles running all logic with update functions. So let's just erase everything that's here right now, because right now all we need is late update. We're actually going to call upon the player camera here. So let's make a variable of type player camera. And I'm just going to call that player camera. And I'm going to make an awake method and call this, I believe. So let's say player camera dot handle all camera movement here in late update. And then back on the camera or player camera, let's actually put in follow player on this handle all camera movement here. Okay, looking good so far. Now, back over here on the player manager, just going to make an awake method, and I'm going to say player camera is equal to find object of type player camera. Easy. Okay, save that. Let's minimize that. Now we start the game here. You can see the camera here is actually in the ground. So, what we're going to do here is we're going to actually edit the camera height by editing the Y on the camera object, and we're going to edit how close is to the player by editing the Z here on the camera pivot. So let's just go to the Y. Let's get a good height going. 1.5 seems to be good, And let's actually, yeah, we can back it off from the player by using the Z here on the camera object. So I realize I've had the game started, so I have to copy this position now, or else it's going to erase my stop. So let's paste the position here on the camera object. Mine is as follows. And let's make this a little bit closer too on the pivot. Okay, now when we start the game, the camera should be following the player, and it should be right behind them. And we're actually going to rotate the camera left and right with this player camera object, and we're going to rotate it up and down with this camera pivot object, but we haven't done that just yet. Just want to make sure the camera is actually working and following the player first. So if I hit the play button here now, as you can see, we're just right behind the player, positioned perfectly. And if I were to move the player, let's actually just do that by opening up the animator here. And you can see the camera actually follows the player. Good, so that's all working as intended. So next we actually have to do a bit more here with the camera. So let's just go up here and start on our input system first. So let's go to Package Manager, and then we're going to go make sure you have Unity Registry clicked, and we're going to go down until we see Input System. It should be, at the time of this video, mine's 1.0.2. Just install that, and this is the new Unity Input System. And then it's gonna give you a couple prompts here. Just wait for all this to go through, and you're going to want to just click Yes, and you're going to want to save afterwards, and it's going to restart your project. Save. Okay, now we're back. We can right click, click create, and then go down, and there's a thing called input actions. It's pretty much off my screen, as you can see, but it's called input actions. I'm going to call mine player controls, and what you want to do is tick this box that says generate C# class and hit apply. We do this so we can actually basically edit the inputs and call upon them in other scripts. So let's double click the player controls here, and on our action maps, let's just make a new one. I'm going to call this player movement, and under actions here where it says new action, I'm just going to call this movement. Now we want to change the action type of this. Let's just delete the binding that's in here. Let's just click on the movement itself and make sure the action type is set to a pass-through and a vector 2. We want a vector 2 because we want the values of horizontal and vertical. Think of a joystick, up and down and left and right. That's 2 values. So let's add a vector 2 composite, and I'm just going to call mine WASD. And then, as you probably guessed, I'm going to make the up key W, the down key S, the left key A, and the right key D. I think the input system has changed a little bit since my last video in the third-person controller series, so this might help some people out who feel a little bit lost towards it. So let's add a new action here. I'm just going to call this camera rotation. Actually, you know what? I'm actually going to call that just camera. Let's keep it very simple. And then under here, again, I'm going to delete this binding. I'm going to add, or rather make this first a pass-through of type, again, vector 2, because we want the rotation values of up and down, left and right. And let's add a binding this time, because the mouse is under binding, and it is delta. So as you move the mouse, you will get values for the horizontal and vertical. And let's exit out and save it. Okay, cool. We have our inputs set up, but right now we have no way to communicate them with our animator to adjust our animation values or our camera values. So let's make a script called Input Manager. And as you guessed, this will just basically commune the inputs and based on our inputs, make adjustments to our other scripts or components like the animator or the camera. So let's call upon player controls, which is that thing we just made. We're referencing the script of the player controls that we just generated. And then let's call upon our Animator Manager. We're going to need that as well because that's how we're going to edit the animator values, which moves our character. And let's make a header. Let's call this player movement. And this is just going to be some variables we get for our movement. So we're going to want a public float for the vertical movement input and a public float for the horizontal movement input. So again, think of your joystick or the WASD keys. W and S will be your vertical, and A and D would be your horizontal, up and down, left and right. Next, let's make a private vector 2. We'll call this the movement input, and this is going to be the raw input we fetch from the player controls. So we just made that with WASD keys, and I'll show you what I mean. It's going to make a lot more sense momentarily. But we're going to split that into 2, basically, into the vertical and horizontal, because we get it as a vector 2 variable. We can then split that vector 2 into 2 separate numbers, vertical and horizontal. So let's go and say, let's make a header here. Let's call this player, actually, let's just call this camera rotation. And then let's make a public float, again, the exact same thing, vertical camera input and horizontal camera input. And then we're just going to make a private vector2 for the camera input. Because as we just did in the player controls, we made our movement and then our camera's movement. And they are both a vector2 pass through. So we can actually get values from the player controls as we press those keys or move the mouse. So how do you do that? Well, it's very straightforward. First, on the awake method, let's call our animator manager, and that equals get component animator manager. And we actually don't need to call our player controls, and I'll show you why right now. So we're going to go down from that, and we're going to say on enable, and we're going to say if our player controls equals null, which it will be if it's not called, we're just going to say player controls equals new player controls. And then we're going to actually lay down some logic here. So we're going to say player controls dot player movement dot performed plus equals I equals greater than movement input equals I dot read value. I know that syntax is weird, but all that basically means, vector2, is that as you press the player movement, so the WASD keys, it's going to basically take the values and put them on this variable right here. So if you're pressing the WASD keys, it's going to feed the values back to this variable. And we're going to do the same thing for the camera. We're going to say player controls dot player movement dot camera dot performed plus equals I equals greater than camera input equals I dot read value vector2. So I know the syntax is a little strange probably for some people, but again, all this means is as we're moving around the mouse, it's going to feed the values from the mouse back to that variable camera input. And then we're going to say player controls dot enable. And then we're going to say on disable player controls dot disable. If you guys want a really good explanation for this, I actually made some visuals for it too in the third person controller series. That's an entry level series. I suggest you check it out. I go into a lot of detail on the movement and the input system. So next, let's make a public void for handle all inputs. So we're going to want to basically handle our movement input. And in the future, we're going to want to handle our camera input. And, we're going to want to handle our sprinting input in a couple of videos time, or our running input. That's just an example here. So let's actually start off with our movement input. We're going to say private void handle movement input. And what are we doing? Well, as you know, we want to edit our animator values, right? So we want to get our animator values based on how much we're pushing the joystick or the WASD keys. So let's say horizontal input or movement input is equal to movement input dot X, and vertical movement input is equal to movement input dot Y, because remember, we are taking these values here from this. So we're taking the horizontal and vertical movement input from the movement input, which we're getting from the player controls, which we get when we use the WASD keys or the joystick, if you set up the joystick. And then we're going to say animator manager dot handle animator values, and we're passing through our horizontal movement input and our vertical movement input. So now when we use the WASD keys, when we call this function that is, we're actually going to be editing our animator values depending on how much we're moving the joystick or pressing down on the WASD keys. So now, likewise, let's do it for our camera input. Let's make a private void handle camera input. And we're going to say horizontal camera input equals camera input dot X. And then we're going to say vertical camera input equals camera input dot Y. I hope that is clear to you guys. Now we can just go up here and we can get rid of the pseudocode and actually drop in our functionality. There we go, handle movement input and handle camera input. And we actually need to call this somewhere now because it's not being used right now. So let's go over to our player manager. Let's make our update function. And let's actually call upon now our input manager. We'll call that on awake. We will say input manager equals get component input manager, because the input manager rests on the same game object as this player manager script. All right, wonderful. Now we can actually just say input manager right here on the update functionality dot handle all inputs. Very nice, very clean, very simple. All right, so moving along briskly here. Now if we go into the game, as you can see, we can actually move our character with WASD keys. And you can see the values changing there in the input manager. But we have a problem. The problem is we can just walk right through a wall, and that's not what we want. So let's change that. Now in this tutorial, we are using root motion. So let's actually add a rigid body and a capsule collider. But if you guys don't want to use root motion, check out my third person controller series. Again, you can easily make the adjustment for this series if you'd like. So let's make the, let's just edit the values here until we got something that looks like it fits around our character. Yep, that looks good. Okay, so on the rigid body, we want to open up the constraints tab here, but first I'm just going to move this. Oh, I gotta unpack the prefab first, of course. Prefab, unpack completely. I just like having my rigid body and my capsule collider right at the top. It's just preference. Okay, now on the rigid body, let's freeze the rotation on the constraints here on the X, Y, and Z. We don't want any rotation. We're gonna do the rotation ourselves. And we should be good. Okay, now, yep, we are good to go. So we can walk left and right, forward, forward, left, forward, right, backward, left, backward, right. And as you can see, apply root motion is ticked. So we are using our animation's root motion to walk. Again, if you don't like that, you can just not use root motion and set up some walking speeds yourself. I've done that in another series. So let's go over to the player controls. Just note, though, Resident Evil does use root motion for the walking. It makes it seem a lot more, I don't know, there's something about that slow, rigid creepiness that makes the Resident Evil controls so cool. All right, so let's call upon the input manager here in the player camera. And we're going to need to use an awake method again. And there should only be one input manager. I think you can say player.getComponent input manager. This might not work, though. I'm just going to try it. I think it does, because we've already dragged our player in on the variable in the inspector, so that might work. Let's just say float look amount up and down, and then float look amount left and right. So remember I said before we were using the player camera game object to look left and right, and the pivot to look left or up and down. You can even change that to look amount vertical and look amount horizontal if that makes more sense to you. Entirely up to you. It's all the same, really. So basically, one of these is going to be referencing the main game object. One of these will be referencing the camera pivot game object, and we're going to adjust their rotations with these variables. Now we're going to say float maximum pivot angle and float minimum pivot angle. And you're asking, well, why are we doing this? And this is just so we can't look, like if you look up forever, you want to hit a cap. Otherwise, you'll just keep looking up until you rotate all the way around. And that just feels strange and will make the controls feel really weird. So let's go down here now, make a private void rotate camera function. And this will handle our camera rotation. And all we're going to say down here, this one's going to be a little more complex than the follow player function. Look amount vertical is going to be equal to look amount vertical plus input manager. Goodness, I can't type. Dot horizontal camera input. And then look amount horizontal is equal to look amount horizontal minus input manager dot vertical camera input. Okay, looks good. Now right below that, we're just going to say look amount horizontal is equal to mathf.clamp. And we're going to clamp that between basically our minimum and our maximum pivot angle. So let's just say look amount horizontal, minimum pivot angle, maximum pivot angle. So basically that'll lock the values. Oops, I actually said mathf clamp 01. It's just mathf.clamp. And that will basically lock the values between the minimum and maximum. We'll not be able to go under or over that. All right, next, right up here, let's make a vector 3 camera rotation and then a quaternion target rotation variable. And then right below here, let's say camera rotation is equal to vector 3.0, and then we're going to say camera rotation.y is equal to look amount vertical. And then we're going to say target rotation is equal to quaternion.Euler. Then we're just going to say camera rotation. Then we will say target rotation is equal to quaternion.Slurp between the transform.rotation and the target rotation. And then by the camera smooth time. Okay. Then we're just going to say transform.rotation is equal to target rotation. So I hope that makes sense. And now we have to do it again for the camera rotation.x. So it's the exact same thing. Camera rotation equals vector 3.0. And it will be camera rotation.x equals look amount horizontal. There we go. And then we're going to say target rotation equals quaternion.Euler, camera rotation. And then we're going to say target rotation equals quaternion.Slurp. But this time we're actually going to reference our pivot object. So we're going to say camera pivot dot local rotation, our target rotation by our camera smooth time. Because remember I said before, we're changing the up and down by changing our camera pivot's game object's rotation, and the left and right by changing the player camera's game object's rotation. And we're just going to say camera pivot dot local rotation equals target rotation. Okay, very nice, very clean, very neat looking, and that should work just fine. So that is pretty much identical to what's above here. So we're just changing the camera pivot game object with one rotation, and the other rotation we're changing the player camera game object. Okay. Yep, that looks good. Let's check this over before we move on. All right, let's save that. Now we can actually say rotate camera up here under handle all camera movement. Apologies if you guys hear some noise. I got the windows open. It's very hot here today, and I hear some cars passing by. So let's say public input manager here on the player camera, and we can drag that in. Yeah, okay, so the input manager did not work. So we actually have to drag that in ourselves or call it on an awake method. So here on the awake method in the player camera, we can just erase that. Or you can use find object of type. I'm just going to drag it in the inspector here. So let's drag in the player. Excellent. Now if we start the game, there we go. We got some camera rotation. And that's working just fine. It locks up on the minimum and maximum pivot angles, and we can move our player. However, as you can see, we don't have player-based or camera-based movement right now. Our player moves freely independent of the camera, which we don't want. We want our player to basically walk in the direction the camera is facing, as is the case with the Resident Evil 2 remake. So let's add a component here on our player, and let's call this player locomotion manager. Let's create and add. Let's double click that, and we're going to erase the start and update functionality. And up top here, let's start off by making a header. Let's keep this all nice and neat. Just going to call that camera transform, because we do need to reference that. The movement is again based off of the camera's direction. So let's say public transform. Let's just call this camera holder transform. I think that's just called player camera, actually. We could just call it that. But anyway, let's make another header and call this movement speed. And let's just say public float rotation speed. And I'm just going to initialize mine at 3.5f. This is, again, how fast your character is going to rotate. And then let's make another header down here right below that. And we're going to call this rotation variables. Whoops, there we go. Okay, let's start off by saying quaternion target rotation, which is the rotation we want to be at. So I'm just going to make a line of comment here saying the place we want to rotate. And then let's make another quaternion player rotation. And this is basically the active rotation. The place we are now is constantly changing. So if the camera's facing one way, you want to rotate towards there, but the player is currently rotating towards there. This is the current rotation. You'll see what I mean. It will make sense in a second. So let's just say a public void here for handle all locomotion, and we're going to encapsulate some stuff in here. So we want to handle our rotation. In the future, we're going to want to handle our player falling. I like encapsulating all the code like this because I find it makes it so much more neat and modular, and if something breaks, it's very easy to trace it back to one isolated function. So let's say private void handle rotation, and I'm going to say target rotation is equal to quaternion.Euler, and then we're going to say 0, and then we're going to say camera holder transform.Euler angles.y and 0, because we only want to basically rotate towards one direction. That is the direction the camera is facing. And then we're going to say player rotation is equal to quaternion.Slurp between the transform.rotation and our target rotation. And then we're going to do that by the rotation speed times time.delta time. Then we're going to say if input manager. Whoops, I actually have to call upon that first. So let's call upon our input manager. Variable of type input manager up here at the top, and we can do that in the awake method. It sits on the same game object, so we're simply going to say input manager equals get component input manager. Excellent, good. Okay, so we're going to say if input manager dot vertical movement input does not equal 0, or our input manager dot horizontal movement does not equal 0, we're going to rotate our player. We don't want them rotating if we're not moving. We only want our character to rotate if there's some movement input. And then we're going to say transform.rotation is equal to player rotation. Okay, good. Now we can just erase this, and we have our encapsulated code. Now we have to call that. So on the player manager, we're going to use fixed update because anything moving a rigid body should be called on fixed update. So we're just going to call upon our player locomotion up here at the top. And we're just simply going to say player locomotion manager equals get component player locomotion manager. And then under the fixed update, we will say player locomotion manager dot handle all movement. And we'll be calling that on, again, the fixed update because we're utilizing a rigid body, and anything with movement on a rigid body should be used on the fixed update. Likewise, I like having my camera on the late update. It looks a lot smoother. So let's save that. Looking good. Okay, now on the player camera, yeah, no, that's all good. Let's drag in the camera, our player camera, and the camera holder transform here. And again, we can rename that variable if you guys want to, because I like keeping it the same. So let's rename that to just player camera, because I want our game objects the same as our variable if we're going to drag them in, because that way if something ever becomes unlinked and we're a long way down the line, we know exactly where it goes, because that stuff can get confusing rather quickly. All right, let's start the game here now, and as we start, you will see that we actually are moving, and we're moving in tandem with the camera. So basically, our player will always rotate towards where the camera is facing as we move, and that is just like Resident Evil 2, at least the remake. So now you guys have a fully functioning locomotion system. Now, in the next video, we're actually going to start tackling the running functions. In Resident Evil 2, you begin to run if you hold down, I believe it's on the left joystick. So we'll get that on the go too, and we'll handle our running input, and we'll dive in further with our animations. So I hope you guys enjoyed this video, and I hope you guys are enjoying the series. If so, please don't forget to drop a like and leave a comment, because it genuinely does help my series get around. And if you're feeling super generous, check out my Patreon below, and I will see you guys in the next one.